Okay, so we are going to use the Staplet today in order to explore this problem. Before I do that, and I will go to that app in just a second, I'm going to show you guys, and it will be useful actually for you to see this example, because in your homework tonight, you will have problems where it will be extremely helpful to use that applet. But in this one, I want to talk about what we have going on. It says that below is the data from one group of intro stat students who used rubber bands in order to tie them to the bottom of a Barbie's foot. And they kept stacking these rubber bands and saw how low the Barbie's head went to the ground in centimeters. So what you have here is with 0 rubber bands, it would mean that the Barbie itself, okay, is 30 centimeters from the lowest point to the top of the rubber band. If you have 1 rubber band added, you'll notice that there's 5 centimeters added with that 1 rubber band. Then when you have 2 rubber bands, it looks like it goes up a little bit more and more and more. What you need to think about is that with rubber bands, they begin to stretch out even more as you add rubber bands. If you were thinking about affixing these to the bottom or the feet of a Barbie. What we have going on here first is identify the explanatory and response variables. The explanatory in this is definitely the number of rubber bands. That's explaining why there's a change. The response is that the lowest point of the head is going further and further down. It says here, what type of variables do we have, categorical or quantitative? These are clearly both quantitative. Anything this unit, has to be quantitative data because of the way that we're putting this into the calculator. And now here's the heart of the problem. We're gonna use this applet in order to make a scatter plot, and I'm gonna show you some other features of that really awesome applet. Okay, so I'm gonna go to the one that we use typically, Staplet.com, and I'm going to show you that one. So let me pull it off to the side here and adjust my window a little bit so that we can be looking at both things at the same time. So what I have is I have this data down here that I'm going to put into this. So here, I should have backed up. Let me back up. We're going to be actually looking at 2 quantitative variables. We've been using 1 quantitative variable, single group, but now we're actually looking at 2 quantitative variables measured against each other. It's asking specifically, what is the explanatory? The explanatory is the number of, I'm going to put RBs, or rubber bands. And this, the response is going to be the lowest point of that the Barbie reaches, but I'm just going to put that for now. So my explanatory variables, here they are. I'm going to hit 0, enter, or space bar. Then I have 1 rubber band, 2, 3, 4, 5, 6, and 7. It's going to be very important that you make sure that there are spaces in between these, and these are going to be ordered pairs, so you can't jump around anywhere. You have to put now, first and foremost, 30, then 35, because it lines them up as ordered pairs. 48, 55, 60, 67, and 76. I'm going to now hit begin analysis and look at what we have, a beautiful scatter plot where we can clearly see that as the number of rubber bands increases, so does the lowest point of the Barbie's head. So this means, by the way, that the Barbie is 30 centimeters. So it would be like taking, this is an experiment where you essentially start on a meter stick and you put the Barbie's feet at the very top with no rubber band. So the Barbie is hanging with her head down, and that would mean that her head hangs down 30 centimeters. And then when you put 1 rubber band on the bottom of her feet and you let her dangle, she now is at 35. Then when you have 2 rubber bands, she's at 46, 47, 44. 44. So you can see that that's what we have going on, but there is an extremely strong positive linear correlation. Okay, the next thing that you'll notice in the Staplet, this is so awesome, you can calculate that correlation that we were talking about. A correlation right there is 0.997. That is almost perfectly linear data. In fact, I think this one is throwing it off a little bit. But that's almost perfectly linear data because an R of 1 literally means every single point is on the line. This is extremely strong. We're going to also be calculating least squares regression lines, and this applet does this for you. This is a beautiful, beautiful program. So make sure you guys use this tonight. It's a lot easier to actually put them in here than have to do these by hand and try to figure out a scale. So if I were you, I would do tonight's problems in this applet. I would take a screenshot and insert that into your work. And that is all for this.